Hello, everyone. How's it going, everyone? So nice to see you back again. Give me just 1 minute. Need to finish this up, and let me know if you can hear me like correctly or something like that. And if there's some problems with audio or something, let me know, please. Hi, everyone. Hi, Oscar. Oscar is OCOSCBRHRR. I'm going to assume that he's Oscar. Hi, Oscar. Hi, Twin Star. Hi, Circuit Student. Hi, Star Fargo. Hi, Circuit Student. So nice to see you again. So yeah, welcome everyone. Welcome back and welcome to another stream of this Global Hack Week season launch. So nice to see you everyone right here. Here in Mexico City is around 8 p.m. We are almost ready to go to bed because tomorrow is Monday and it is a new week. It is a new beginning. So yeah, let's just jump in and start with this. So, what are we going to do today? Today, we're going to create an image classificator. So, if this is the first time that you're hearing about image classification and you have never touched AI or Python or things like that, don't worry about it. Like, you don't need to worry about anything. We're going to learn everything that we need today right here in this workshop. So, yeah, let's just begin. Let me just share my screen really quick. And you should be seeing it right now. Yep, you should be seeing it right now, I think. Give me just 1 second. There you go. So yeah, we're going to create our image classificator today. So welcome back, everyone. If this is the first time watching me, let me introduce myself. My name is David. You can call me David, the Wood, or however you want. Some persons call me Dave. Other ones call me Lazaro. Whatever works for you. I'm trying to find with anything. So yeah, I've been like a year and a half, something like that, a coach here at MLH. I was also a software developer engineer at Spentech. I need to change these slides. I'm currently a workflow engineer in another company called Blend Labs. And I was once upon a time a GitHub Campus expert. I think my time as a campus expert is going to finish like this month. I'm going to become a GitHub Campus expert alumni because I've already graduated. So pretty much yeah. I really love hackathons. I really love the MLH and see like all the hackers working around in like the hacker community that we have here at MLH. So if you want to become an MLHer, like for example at the MLH Fellowship, or if you want to hear or have questions about the MLH or how to become an MLHer, or if you want to found a hackathon, uh, please reach me out on LinkedIn or on my GitHub or one of my social media. Send me a message. I'm totally going to respond to you. And yeah, I love hackathons that much that I found a hackathon here in Mexico City. Well, not in Mexico City, but another city in Mexico called Monterrey. So it is called Tigre Hacks. So if you love hackathons, please reach me out. And yeah, I was once upon a time a fellow on the MLH Fellowship on 2022 at Meta. And I'm currently building a Texas startup, research tools, and more. So yeah, let's just continue with this. So before getting into coding or something like that, we need to understand the basics. So first of all, what is image classification? Image classification is a task in computer vision where an algorithm or machine learning model is trained to categorize images into predefined classes or categories. The goal is to teach a computer to recognize and distinguish between different objects and patterns. Uh, what do you mean, Twinkle Star? Are you not seeing what like, are you not seeing what I'm sharing, or am I tripping, or did something wrong? Can you hear me? Hello, testing, testing. Testing, testing, testing. Uh, am I tripping, or is just Twinkle Star? Like now, can you all hear me, or? Oh, okay. Yeah. Thank you so much. I was tripping. So yeah, let's just continue with this. So yeah, what is image classification? Image classification is a task in computer vision where an algorithm or a machine learning model is trying to categorize images into predefined classes or categories, and the goal is to teach a computer to recognize and distinguish between different objects and patterns within an image. Um, mm, 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 mm. Okay, cool. Yeah, I was just driven by the message. So yeah, this is typically achieved by fitting the model with a large data set. And this data set mostly is going to be labeled with image where each image is associated with a specific class label, right? So during the training process, the model learns to identify features and patterns within the images that are indicative or of each class. And once trained, the model can then be used to predict the class of new unseen images with a certain level of accuracy. So why image classification? What is so important and where are we using it? So we're using image classification like everywhere right now. Like we're using on medical applications, like trying to detect some syndromes or cancer or things like that, or bad conditions under some organs, X-rays, MRIs, and CT scans. Also, we're using it on remote seeing or remote sensing, where we use environmental science, agriculture, urban planning, all this stuff. Image classification is being used to analyze satellite images, and it helps in monitoring land uh, use changes, assessing crop health, designating deforestation, and managing natural resources. Also, it is super important for security because image classification plays a crucial role in security and surveillance system by automatically identifying objects, people, or activities of interest in video streams or still images, right? So it helps in detecting intruders, recognizing faces, and monitoring traffic flows in public spaces. So as you can see here, we're using image classification in different parts. All of those are super cool, super important. Like the following one that we're going to start explaining, which is autonomous vehicles. Like, Tesla has this AI that can all has like all this complex system that can understand like what the cameras are watching, and they are being trained to understand like which object is a road, which one is pavement, which one is a moving car, and things like that. So autonomous vehicles are one of the coolest things that we're using right now for understanding how computers think and how computers can identify images and objects in those. Also, we're using it on retail and e-commerce for trying to check out which ones are like the most buy items. Also, so we can have like recommendation systems, and also to categorize products and analyze which one of the products are already finished, and we need to develop more products, or we need to put more products there. And also for providing personalized recommendation leading to improved user experience and increased sales. Also, we're using it in quality control manufacturing. Like this example shows like a T-shirt that, or like yeah, like a T-shirt or something like that that has a hole or has like a, I don't know, like chlorium or something like that, that just made like a little troll right here in the T-shirt. So yeah, this can detect flaws in manufacturing components, classify products based on visual attributes, and optimize production processes. So how does image qualification works? Like, is it really hard? So it is kind of complex, like in the depth, because it has a lot of mathematics right there that actually take care of doing all this stuff. Don't worry about it. Today, we're not going to watch anything about mathematics or convolutional neural networks and things like that, because I don't want you to trip. I don't want you to get like super like a mathematical hater or something like that. Like, I don't understand maths. I hate maths. So I'm not going to program anything. No, don't worry about it. We're not going to see that. So yeah, we're the first thing that we're going to do is some process called data collection and preprocessing. In data collection, we're just going to get a large data set of images with corresponding labels. These images should represent different classes or categories that you want the model to recognize. And the preprocessing is where we actually do all the steps, where the first one is the data competition, then data noise, then data transformation, then data reduction, and data validation, right? So there's a really cool thing called feature extraction. That is one of the processes that we do, where we extract meaningful features from the images that can help distinguish between different classes. And this step is crucial for representing the visual information in a way that the model can understand. So that is cool, right? We're using just like capturing features and points and coordinates that we can identify that same images have. And we use something called geometric feature net that you don't need to understand right now. And after that, we do some more processes that are like more in depth, like local geometric features and feature similarities to try to identify which features are similar to others in images, right? And after that, we use more techniques like having convolutional networks, like convolutional neural networks, and using feature techniques to try to extract important information that we can see in images, such as BG, ResNet, Inception, which have learned to extract hierarchical features from images through training or on large scale datasets like ImageNet, which is like a super really big dataset which has like millions of images from all the internet. So the main question is, are we going to hack now? The answer is no. Need to still understand some basic stuff before going to hack. So we need to learn how to implement some things like model training, validation, inference, and some libraries that we're going to use today. The first one is model training. We're going to choose an appropriate classification model architecture, such as the convolutional neural networks, and train it on the preprocessed dataset that we're going to use today. After that, we're going to use something called TensorFlow to try to train our neural networks and our machine learning model, so we can train our model to identify like a really cool data set that has some numbers, but that is like a spoiler. So yeah, during training, the model is going to learn how to map input images to their corresponding class levels by adjusting internal parameters or weights based on provided training examples. Like here we have the data set creation. After that, we go to target column selection, then train, then test, then split, feature set generation. We're going to preprocess our machine learning pipeline. After that, we're going to do more stuff that we're not going to touch like today, like the evaluation or things like that. Well, we're going to touch a little bit of the evaluation, but for now, I don't want you to trip up into these processes because for now it's a lot of information. But yeah, you don't need to understand anything of this. So this is what we're going to do. We're going to use a number, like a handwritten number that we're going to use inside of our data set, and we're going to check out how we can identify this. And the main question is, hey, David, how can I make the computers to understand how this images actually looks, or how these models can understand which image is this? Like, is there any way? The answer is yes. Are you seeing the color of this black number? Well, black and white number. Have you ever heard of something called RGB? So RGB is something that we actually call for creating colors with red, blue, and green. But here we are not using RGB. We're just using one density line, which goes from 0, which is denoting for black colors, and 255, which is for denoting white colors. Let me show you a picture of that. 0 to 255. There you go. Oh, no. There you go. Yeah, you're seeing, you should be seeing this right here. And let me zoom this up. Yep, there you go. So yeah, as I was explaining, here we have like just like one line of colors, and this line of colors is actually going from the number 0 to number 255, which is 0 is used for black colors and 255 is used for white colors. So we're using these numbers for identifying which colors are we using inside of this line, right? For just trying to plot colors in 1 pixel. So if you imagine it, or if you think about it, like one image is just a bunch of pixels, right? Like we can see right here like image to pixel to 255. Yep, there you go. We can see it like right here. We have this frog like give me just 1 minute so I can zoom it a little bit more. We have this frog which is on black and white, and basically what we're doing is like just trying to get the colors of each one of the pixels that we're using in each image, and we're going to try to understand which colors are being used on each one of the pixels. So each color is a number, right? It's a number between 255 and 0. So this is going to allow us to get into something like this, into something called image data. As you can see here, this 8 and this 8, like 108, is not just an 8. It's a bunch of colors that are being displayed into a matrix. And basically, it is not an image. Like your monitor is actually processing like which number is being passed through me so I can display a color in each one of the pixels that I have on my monitor or on your computer or on your TV or something like that, right? It is just information that is being sent by your computer through electricity. And based on that electricity, your monitor is going to use light, so that light can be shown in your computer or in your monitor or your TV or something like that. But you can see here, these colors, this 108 is just a bunch of numbers which represent which color should I color in your monitor or something like that. So yeah, we're going to do that. And based on that, we can understand that, hey, I'm seeing that I have some colors or some numbers inside my matrix, which that matrix is actually representing color, right? Here we have an input, which is just a bunch of ones and zeros. For now, just imagine that they're ones and zeros. Don't worry about it. Like the other part of understanding the 0 to 255 number. But imagine that our models or our computational neural networks are going to identify which colors are we going to use inside each part of the images. So we're going to do some linear algebra functions or mathematics, so we can pass that data, but already processed, to our convolutional neural networks. So until now, everything that you're going to see here is going to pass through through our neural network, but usually images are a little bit bigger than the ones that our neural networks can process. So the first step that we're going to do in this workshop is going to resize this image that we're seeing right here, and we're going to pass our matrix into one big array of 784 pixels, which is just a representation of 28 times 28. So we're going to pass that to our neurons so they can make all the magic behind. Okay, this is a lot of information. This is a lot of mathematics. So don't worry about it. If you don't understand anything, don't worry. Before getting into this example, I want you to show you a really cool tool that you can Google super fast right here, like what? Like a teachable machine, which is a really cool Google page that you can use on your computers. Let me show you the link right here. And you should be seeing the link right now. And give me 1 second until I change the teachable machine. Is there any way to end? Teachable machine. But I want to change the, oh, there we go. English. There you go. Yep, we're going to go into teachablemachine.com and we're going to, yeah, there you go. Now it's in English. And let me zoom a little bit more like this. And let me know if this is enough zoom or if you need more zoom so you are able to see what are we going to do. What would we flatten the image into an array not work with a matrix? For now, don't worry about it. You don't need to understand it. We're going to explain that later. Is that all right? While we watch this, and after that we can explain everything that you want, right? So yeah, what is Teachable Machine? Teachable Machine is a really cool tool that you can use for training your own models, like inside your computer. You can use it anywhere, like however you want. The cool thing about it is that you can just make like an image project. You can also make a auto classificator, a post classificator, and things like that. For now, what I want you to do is to go and click into the image project and click into standard image model. And let me, yeah, okay. You should be seeing me in two parts, like right here. Um, yeah, you should be seeing me like this. And let's see, I have an avocado right here. In your home, like wherever you are, you can use whatever you have near to you. Uh, I have uh, I have a cup right here, an angel hack cup like this, and I have an avocado. So I want to make a classificate an image classificator that can classify me, but with an avocado, and me with a cup of angel hacks. So what are we going to do is we're going to hold on record. Well, first of all, we're going to click into class so we can create our own label, like we're going to do right here. And in that label, we are going to add the name of the thing that we want to classify. In this case, I'm going to name it like David with an avocado. David with an avocado. Cool. And after that, I'm going to record myself holding the avocado in different poses, like this. I'm going to move the avocado like this, a little bit forward, a little bit closer, with me, my face just like this, and then with the avocado a little bit like this. So I think something around 400 should be enough. And the second class is going to be David with Angel Hacks cup. And I'm going to do the same thing, but for this one. So I'm going to record myself on different ways and different angles of this cup. So the classifier can watch me like in different ways, different angles with the same cup. So far away, a little bit closer. And there you go. We have something like similar. Let me just hold it for until it gets to 26. Yeah, something like that. So yeah, why is so important that we have 428 and 426 or something like the same amount of number for our training data? It is because if we train, imagine for example the first time that we have, like for example, I don't know, let's suppose the following case, and let me record me again, and let's assume that we are a baby. Where this guy? Let's imagine we're this guy, and this is going to be the first time that we see a cat with a baby. This is the first time that we're going to see a cat or something like that, or well, a dog. This is the first time that we're going to see a dog in our life. So this could be the first time that we see a dog, and when we try to understand, hey, what is this animal? What is this big thing that I'm seeing for the first time in my life? And maybe my father, my brother, my mother, whatever you want, is going to say me, hey, that is a dog. But usually dogs say wow, right? So usually I'm going to think like, hey, that is a wawa. That is a wawa. That is a wa, because I don't know how to pronounce words, right? Because I'm a baby. So the second time my family goes to the park and I see a different dog, like this one, and they told me that, hey, that is also a wawa. So maybe the third time that we go to the park or we're in the street or something like that, I see a different dog like this one, right? this is different than the dogs that we have seen before, right? This dog doesn't look like this or to this dog, right? But my mind is going to tell me that, hey, that animal barks or that animal makes a sound that is also similar to wow, right? To just a bark. So I'm going to think like that probably is going to be a wawa, and the same thing is going to happen if I see the next dog, the next dog, the next dog. So when I see a new dog the next time, I'm probably going to think that, hey, that probably is a wawa, or that probably is a wawa. And when I'm getting older and older, I'm going to start thinking that, hey, that looks like a dog. That is actually a new dog that I have never seen before. But now I know that there are some things called breeds, dog breeds. So yeah, I'm going to start training my mind to understand what a dog is. And based on the things that I've seen before, I'm going to understand what is a dog and how, what does a dog make. Like a dog has four legs, it has like maybe fur, and also has like a little nose like this, right? So I'm going to assume that, hey, that is a wawa. And the first time that I'm going to, but maybe in this whole time I've never seen a cat, or I'm just seen one cat, like a Maine Coon, like one of these cats, right? So hey, this cat has also four. Well, these animals also have like four legs. It also have four. It also has paws and has like a nose like that. So because this is the first time that I've seen that, I've never seen a cat before, right? So my mind is going to probably tell me, hey, that is a wawa too. But that is incorrect, right? That is a cat. Cats doesn't make like wow or doesn't bark or anything like that. They make meow. So maybe that is a meow meow. But because I've never seen a dog before, I mean a cat before, I'm going to assume that that is a wawa. So you're seeing the problem here. We their whole life we have seen just dogs, and if I see a different animal, or if the amount of dogs that I've seen in my whole life is greater than the amount of cats that I've seen in my life, this is going to this is going to be hard for us to understand. Like, hey, this is a meow meow. Cats make meow and things like that. So this is actually overfitting, something that we call machine learning overfitting. That is just having more data for overfitting and machine learning. It's just having more data for one training data than another, and it looks like this, right? We're going to start having some problems because we are training our model to have more data for one class than another. So yeah, this is why it's so important that we have this the same amount of images inside of our classes, right? So okay, if you have reached this part and you have already recorded yourself or have already your image classification, you can click on train model, and your computer is going to start training all the stuff that you need. It's going to prepare your training data and all the stuff. Don't worry about it. Don't worry if it takes like a little bit of time. It is going to now start doing some stuff or not. Yep, there you go. It is training. Okay, cool. So it has to start training, and after it trains itself, it's going to show us a preview of our camera or like your camera or something like that, and it's going to start making classifications. It's going to start learning how what is it looking and what is not, right? So it is almost finished. So let's just wait a little bit more, and ta-da! What would happen if I show an avocado like this? Okay, it doesn't change. But what happened if I changed it to, there you go. Now it's assuming that we have a bottle and it's like this. Now it starts tripping. No, not tripping, not tripping, not avocado. Okay, cool. So our image classificator has to learn how to classify things without the necessity of doing something, right? And if I put the two things, it's going to say that looks more than avocado, than this thing, right? Than a cup, right? And that has a lot of things to do. Maybe it is because of maybe it's because of the angles that I recorded myself, maybe the amount of images and more stuff. But yeah, as you can see here, it is as easy as that. If you can try it on your home, this is a really cool tool that you can use for anything. And if we add a new class like a webcam, and let me just record myself like this. Hmm. Let's wait a little bit more until it catches up like all my angles. I think that should be enough. And if we try it again, but like with a new class, in this case, this new class is going to be like just myself, and my classificator is going to be able to classify between each one of these classes. And until like this class should be named just David or something like that. But yeah, after that is going to learn that I can be just me alone, but I can be also with a avocado, or I can be with a cup, right? As if we want to assemble this, would it be possible? Yeah, you can use it like you can use it on your web pages, and I'm going to show you how you can export that model and how you can use it on your page. And we're going to use ChatGPT for that. So as you can see here, the third class is the one which is like bigger. We have like right here, have just David, me with a cup, then me with avocado, then me alone, me with a cup also, avocado, David. It is funny. So yeah, how we can use it on our projects, right? So that is the cool thing. Teachable machine allows you to export this model and use it wherever you want. Like you can use it on TensorFlow, you can use it on TensorFlow JS. So if you want to use it on, let me shareable link. When you upload your model, oh yeah, upload my model. So yeah, if you want to use this like in your web application, you can start using this with this link that says your shareable link. So give me just 1 second and JavaScript, and okay, let's see how we can use it like super quick. And let me just open a new Replit and blah 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 homereplit.com. Let's oh, I'm not signed up. Okay, so where can I use it? I'm going to assume that I can use it on a GitHub Code Spaces. So let's go to GitHub. I'm going to share with you like that link, but just give me 1 quick minute. Let's start a new repo called image go ahead week image classification page. And I'm going to be the owner, and also the description is going to be hacking your first image classification page. So we're going to add a README and create a new repo. And after creating our new repo, we're going to open a new code spaces. For now, don't worry about it. I'm just going to try to make like the fastest page ever. And for that, I'm going to use ChatGPT. So let's open a new ChatGPT like this. And let's ask, hey, can you modify this code so it has a title, so it has a Vercel style, and also have a title that says hello global hack week, and add an avocado, comma soda, comma person emoji. Oh freak, I didn't oh, there you go. Oh, like that, and send. Oh, Hershey more blah blah versus that blah 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 emojis avocado. Okay, cool. And okay, it's already writing like the page that we're going to use. While it writes that, we are going to see that a new code page has been created. So let's create a new index.html. And let's add a new extension, which is going to be live server. And let's install live server. Okay, installed. Let's go into ChatGPT and copy this code. Oh no, this one. This one. Go into index.html, copy, then open with live server, and let's see if our page is running. I know that there is a lot of things that I'm doing right. Like, I'm sorry, but let's just start this. Allow, and let's see how this would look. Okay, cool, nice. So cool. It is working, right? Like we're seeing that we can use it in our pages. Let me just zoom in a little bit more, and now you should be able to see me. So yeah, see, like it is like almost like showing me like I have my avocado or I have my angel Hugs cup. I have my avocado right here, just me, cup, avocado, David, Angel Hugs, avocado, David. Right. So this is really cool. Like we have managed to create an image classificator and add it into our web page without the necessity of coding anything. Like it is really cool, right? We can make our own projects for understanding a little bit more of this stuff, right? And next question: what happens if you hold bottom? If I hold both, it says that I have an avocado, but maybe that is because of the angles of the photos which I trained my model, or maybe it has to do with the angles of the avocado that I hold it, or maybe I hold it like this or like this, and things like that. Maybe the colors, the pixels, it has a lot of things to do, right? So yeah, for answering slow jams, give me just 1 minute. Um, oh yeah, 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 don't worry. Yeah, let's just recap what we did, right? So what we did before recapping, let me push this into our repo and working page. Add sorry, add working page. Sync, and all right, now you should be able to see the web page if you go into this code space. So before the recap, let me post the code space, I mean the repo, so you can use it. And there you go. Okay, cool. So what did we did? What did we do? First of all, we were right here training our pictures and training our model so it can understand like how things work and all the stuff. After training, we have already our preview with all the stuff that shows me if I'm holding an avocado or if I'm holding an angel hog top or if just me and myself, right? So now what do? We go into this button that says export model. You click into it, upload your model into the cloud. For that, you should have a Google account and log into your Google account, just like the normal Google account that you use for traveling internet. And after that, you're going to receive this code, and just the only thing that you need to do is to copy it and then go into the code spaces. Well, go into GitHub, into the repo that I shared with you in the chat, and you're going to see this code when you open it. The only thing that you need to change is this part, the part that says script. From script to CDM, JS, NPM, TensorFlow, blah, 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 until it finishes. So you raise this up, you copy, you paste it, and you should be seeing again your teachable machine button. And what happened? Oh yeah. Sorry. Yeah, yeah. I'm sorry. It was scenes like from webcam container until the script tag. Again, from line 45 in it. No, from line 44 to line 101. You should erase all this stuff and just paste the new one that you have. And you should be seeing your model. And how you can create a new code space is just go into the repo and click into this green button that says code. Let me just share with you a little bit more. Like this, you should be seeing it. Go into the repo. After getting to the repo, click into code, and you're going to see this part of the menu that says local. Don't click into that. Click into the section that says code spaces, and you're going to see a really big button that says create a new code space. After clicking into it, you're going to, a new environment is going to be created for you. It's going to look like this. It is like a Visual Studio on the cloud, Visual Studio Code on the cloud. You don't need to use your computers. Like if you want to do it on your computer, you can. But we're using code spaces because it is a safe space for everyone in each computer. Like for example, I'm now in a Mac, but I know that we have some folks that use Linux, some other ones that use Windows. So this is like a same space for everyone, and we're not going to have like errors or package errors or things like that. So yep. After doing that, just go into extensions and just make sure that you have live server, and this live server is going to open a new port into your web page so you can use it in your computer, right? So just go into index.html, right click into it, and click into open with live server, and you should be seeing something like this. And just click into start, and you're going to see that we have right this thing. And please, if you are using it and if you have managed to do all the stuff that we're doing right now, please, please, please go into Discord, share a picture or share like a screenshot or something that your model is working. Like if you don't want to show your face, that is good. Like it's not necessary. But for example, just like your hand holding like the avocado, or your hand holding this up, or whatever you want to do, that would be cool. So we can see like what hackers are building and what hackers are actually doing in this global hack week, and so we can show everyone that in this hour we built in less than our image classification page, right? So I encourage you to do it. And until now, does anyone have any questions? Cool. That sounds awesome. Like, what are you planning to do? Are you planning to build like a classificator for water, for filtering, like for social good impact? Or can you tell us a little bit more about it? Or like, what are you trying to do? Like, are you trying to classify like bigger things? Also, this works with other things that just camera. It works also if you want to load your images, your same data set of images. If you go to training machine, this teachable machine, and instead of using webcam, you can add a new class that has your own images that you can upload with add a sample, and you can upload it from Google Drive, or you can use your same images that you have on your computer. But yeah, let's just continue with this. So we have already, well, almost reached like the hour. And if you have any questions, please, this is the time for asking whatever you want to ask. Like, if you have any questions about this, if you have questions about some other stuff before we go into the theoretical part, because now we have to explain some stuff. So give me just 1 minute. And while I'm going to to wait 2 minutes to see if anyone has any questions. And well, I think no one has any questions. So if no one has any questions, let's just continue with this. Uh, okay. Just reading something. Hmm. Oh, your webcam is now showing. Make sure that you enabled your permissions of webcam in your page. Make sure that you went into right here, and before like you click into the right part, like this one, and a new window should be saying like just asking you for permissions, like for using your camera. And before that, I'm just trying to check out something because I think my computer started to trip a little bit. So while we wait, let's go back into the slides. And okay, we have. And are you seeing the slides? Yeah, you are. And let me just zoom it up a little bit more. There you go. And boo, 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 boo. Blah, 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 blah. Okay, yeah. Well, we can continue now. Okay, so we had a question from I don't know if it was Slow Jams or if someone. Oh yeah, DDKER 8520. What will you flatten the image into an array and not work with a matrix? So we do it because we're going to do a lot of stuff right there. And in image classification, we do a lot of mathematical operations with the input data that we're receiving. In this case, the input data is a matrix of 28 by 28 pixels, right? But our neurons have more capacity to work with just full arrays than with matrices. So in the context of this multiplication of matrices, we do this operation, or well, our array operation of the just multiplying or converting our matrix into just one array, because we want that our densescapes of our neural networks or fully connected layers um, can have these input vectors instead of these matrices, so we can transform that image. So we can use each one of those pixels as just one individual input into this neural network. And also, because in this case, if we have like a dimension this 28 by 28, and we want to reduce it into something that our neurons can actually understand, we want to flat all of our metrics, and also so we can just standardize all the pixels that we're going to use it. So our CNN or convolutional neural networks or our perceptrons or more stuff that I'm not going to explain today can understand them and can work better and have like more capacity. So, okay, now we have finished the first example. Now we have finished also the slides. So what are we going to do next? Like after all the stuff, is there still one thing that we're going to do? The answer is yes. We're going to actually work and hack our first image classification model, but in a collab. And also, let me close this up and let me stop the code spaces. And again, if you are just getting into the stream and you want to watch the classification model that we have done into this first hour, uh, you can see the repo right here in the chat. And but if you're not, I'll just give me 1 minute so I can share with you. Where is it? There you go. Yep, this is the collab that we're going to be using, the notebook that we're going to be using today. So let me copy the link and pass it to you right here. There you go. Okay, cool. So if you are right here already, this is the first step that we're going to be doing for our um, for this time. Give me just 1 second so I can make sure that you're not seeing something. Blah, blah, blah. There you go. You should be seeing the page right now, and let me know if this is enough zoom or if you need more zoom. So, all right, yeah, we are going to use our first machine learning libraries so we can uh, use the same example that we saw about training a model so it can identify how to create how to identify different handwritten numbers from 0 to 9. So this is going to be the first example that we're going to do. And the data set that we're going to be using is called MNIST or MNIST, or I don't know how it's pronounced, but it is MNIST. It is basically just a data set of images of handwritten images, and we're going to train our model so you can identify like which number is our computer seeing, right? So the first thing that we need to do is that we need to install some Python libraries like matplotlib, like OpenCV, TensorFlow GPU, and things like that. TensorFlow is a really popular Python library, ML or machine learning library that we're going to be using. OpenCV is another really popular library that has a lot of tools for working with computer vision and things like that. And Matplotlib is a really popular library, Python library that is used for plotting graphics and things like that. So, yep, let's just run this up and just click into here. If this is the first time that you're using Colab, it is a virtual environment that you can have in your browser that can what downloading. Oh yeah. Okay, so this time let's just skip tensor GPU because for somehow it is tripping. Okay, yeah. So yeah, Colab is just a virtual environment that we can have inside of our computer, so we can just run whatever Python code we want, and also we can write Markdown, which is like uh, just formatted text that we can use in our files or in our project. So as you can see here, we have downloaded a lot of stuff that we don't want to see right now. And if we run pip list, we're going to see all the list of packages that we have inside of our collab. As you can see here, it is a lot of packages. We have like thousands or well hundreds of packages right here that we're not going to be using all, but they're important so collab can run without any problems. So after doing that, we are going to import TensorFlow and OS, which is like the operating system library that we can use for just accessing to some files or so for something. And after doing that, we're going to import NumPy as MP, and from Matplotlib, we're going to import PyPlot as PLT. So after that, we want to just config that Matplotlib can be printed inline instead of like in column. And after that, we're going to just config our TensorFlow so it can use this our GPU from our collab, so the training process doesn't have any problems. So yeah, we're going to do this. So let's see which physical device do we have. So we have physical device object name, physical device GPU, and the device type is a GPU. So cool. So what do we need to do now? So okay, we have installed the packages, we have installed all the libraries, and oh my god, it is already the first hour. So before getting into the second part of the process that we talk about uh, where is it? Yeah, there you go. The data composition before removing data noise and removing all the images that we don't want to for the training process. We're going to take a break of 5 minutes so we can go to drink a little bit of water, go for some cookies or whatever you want. Let's take a break of 5 minutes, and after that, we're going to come back and we're going to finish our model. So, if that is right, all right for you, I'll see you in 5 minutes. So, see ya. And we are back. Uh, just 1 minute till I pass this and me get up the banners. And hello, Roshan Kumar. So nice to see you. Uh, okay. So yeah, we are back, and let me know if everyone is like right here already. Uh, Oh, hi, Ridley. So nice to see you. Don't worry about it. Like, until now, what we have done is create our image classification page. We have also trained our first image classificator. Here's the GitHub repo if you want to watch it out. Let me send it again. I don't know if I'm able to. Oh my god, I'm not able to grab this thing. Okay, give me just 1 second until I go right here and I open the repo so you can check it out. How do you open this? Oh, it's like this. So studio code spaces, yeah. No, no, this one. This one, yeah. Here is the repo if you want to check it up, and there you go. So until now, we have just been talking about like how we can create our image classificator. We have created our first image classificator that can classify between avocados, between me, and between cups. So here's all the code that we have been using. You can just open the page. You can check out the code. We have used Teachable Machine, which is this page right here from Google that you can use it for just building image image classificators without the need of using code. It is a really good introduction to image classification. So if you want to check it up, please check it up. And we have also checked out some things like the principles of image classification, how image classification work, what is so important, how we can use it, like which are the steps of image classification, and more like validation, model trainings, and how all this stuff works. So now that we have seen all that stuff, we are working into a Google Colab that we're going to use for creating our own image classificator that is going to use MNIST, which is a training set or a data set of just handwritten numbers data set. MNIST. Is this data set the one that we are going to be using today? As you can see here, it's just like a bunch of handwritten numbers that there are thousands of them on the data set that we're going to be using called MNIST, or yeah. So yeah, as you can see here, we're going to train a model that can just classify the numbers and can identify which number is which and which number is another, right? So yeah, what do you think if we continue? We have just got here. We have installed the dependencies. Let me share with you the collab again so you can use it. And after you open your collab, go here into File, and you're going to see option that says, where is it? Where is it? You're probably going to see an option that says create a copy. So after creating that copy, now are going to be able to use this collab however you want. So we have just installed some dependencies, some packages. We were making some configurations for TensorFlow and all the stuff. And now we are going to get into one of the processes of image classification called the what? I totally forget the name, the data noise reduction and the data completion. We're going to remove all the images that we don't want them. So for doing that, the first thing is that we're going to do is to actually we are going to start loading our training data first. And for doing that, we're going to use TensorFlow, And TensorFlow has already some data sets like loaded in the library. So for any machine learning, in particularly on deep learning, we need data. In our case, we need to access to the data set of thousands of hundred and digits. Lucky for us, MNIST images does just that. Like the MNIST dataset was taken from the reading of U.S. Census Bureau officials and high school students, and is commonly used for test trained simple machine learning models. So the first thing that we are going to do is to just download the package and abstract it into two tuples. The first one is going to be the data shuffle split between training and test data sets. So we're going to use the first data set that is going to be the X train and Y train, and the other data set or the other split is going to be X test and Y test. So we're going to equal to tf.char as that data sets that needs that load data, so we can load the data of the data sets. And after that, we're going to print the X training original shape and the Y training original shape, so you can see it. So as you can see here, we're downloading the data from TensorFlow TF Keras datasets. And as you can see here, we have like 6,028 by 28 images right here, right? Let me choose. Are you hearing me or? Oh my God. Can you not hear me or am I muted or something like that? Uh, Please let me know if you can hear me or if there's any problem with my microphone. Okay, cool, cool. Can you try refreshing the page or something? Try refreshing or maybe checking your permissions. Yeah, no, don't worry about it. Don't worry. If you have any problems or something like that, like, yeah, yeah, just restart, like, just refresh the page, and you're totally going to be all right. And if not, just type in the Discord like the problems you're facing, so we can help you with that, and we can just help you to get into the stream. All right. So yeah, as you can see here, we have just downloaded the dataset, and we have a dataset of 60,000 images, and each image has uh, a 28 by 28 size, right? So now, after doing that, we're going to see that we can see more stuff, like just running more code, like trying to see like the shape of each one of these routes. As you can see here, if we click into print X train and print shape, we're going to see the shape of this, and we are also going to see like how these images look. And as you can see here, like the routes are being coded itself, but we can see each route of our X train. And for each route, we are seeing some numbers. And remember that we were talking about numbers from 0 to 255. Those are colors that we're seeing right here. I don't know why we don't have like the full size, but we're probably like what are we seeing here is an image, but in a metrics way. We're seeing each row of the image of 28 by 28, and we're printing each row of them. And for each row, some parts are fully black, like the ones at 0, and the other ones are already becoming like a little bit more brighter, right? Some of them are already like fully white. Some other ones are like a little bit more grayer than others. Some other ones are blacker. Some other ones are whiter, and things like that. But as you can see here, like we are actually printing an image, which has a shape of 28 by 28. Uh, yeah, don't worry, don't worry. Oh my God, is that like is your name a Japanese name or a Chinese name, or like which kind of alphabet is that? And also, what does it say? Like, is it like a Japanese name or a Asian name or something like that? Oh, it's Chinese. Cool, cool. And like, how can you pronounce? Or like, how can I? Oh, is it sky? Oh my God, that is no. I don't believe it. I'm not really sure if you are making me. Oh my God, is this sky? Wow. Nah, I don't believe you. Like, is that how you type sky on Chinese? Okay, let me see. Oh, your name is Sky. Cool. Oh, got it, got it. Cool. Thanks so much. I thought that that whole thing was like a Sky, and I was like, oh my god, all that stuff for just a Sky. Yeah, cool. And I'm seeing that is Tiankong. Tiankong. Okay. Okay, okay. And is it pronounced like am I pronounced it like correctly, like Tiankong, or how? I know the pronunciation is like super hard in Chinese. Tiankong. Okay, cool. Okay, yeah. Let's just continue with this. All right. So we have just printed our first number, our first images, and as you can see here again, we are already seeing an image, but we're printing only the each one of the pixels and the color that each pixel is representing. So now we want to actually make a subplot where we can see each one of the image that we have in our X-train, and we're going to show the image in a map of grays, and we're not going to have any interpolation. And the title of each one of these image is going to be the class that we are going to use for each one of these ones, right? So if we just click into here, we're going to see that the cell is going to be executing itself. And now that we are here, we are going to see that before preparing the data set, we are going to check up some samples. And these samples or these images that we're plotting are actually the ones that that we're going to use, right? So as you can see here, well, as you can see here, like the main problem of seeing all the zeros is like a super common machine learning problem. And this is why we are going to use matplotlib, because one of the biggest machine learning problems is visualizing data. When possible, it is a great thing, but when not, it is horrible. It is hell. So luckily for us, we have matplotlib, and it is a really cool Python library that we can use for just loading images for mathematical data or things like that. And with each one of them, we can just we can plot an image of 3 by 3, and we can plot like a graph that says like the size of the image that we're plotting, how much pixels that each image has, and the class that that image is representing. So now you're seeing that we have like these 9 classes that we have, right? And the plot that image show that we're using, like right here, is actually converting that digit, or yeah, that digit matrix to all the stored matrices that we're using into a visible image. So yeah, we have saw how this whole thing looks. So this that imp show actually converts that those pixels and those numbers to all to colors. So real cool, right? So okay, so now what else? What do we need to do? Okay, so we have removed already. Well, we have not removed. We have already see how our images and our things that we're going to use for this data set looks, right? So before doing that, we need to prepare our data. So remember that I told you that we needed to convert our matrices into arrays, because this is like the correct way that machines and neural networks are able to work without having any problems. So we're going to actually do that. We're going to check up our 28 by 28 pixels matrices, and each pixel has 0 to 245 value like we saw before. So now we're going to use and to reshape those things into uh, 10,000. I mean, we're going to convert those 28 to 28 matrices into 200. I mean, 784 arrays. so we can just reshape that array without having any problem. So, yep, for that, we're going to use xtrain that reshape, which is a NumPy function that is able to reshape the matrix as an array. And as long the array has like the same shape as the original, right? So we're going to do that for our train and for our test. So let's just run this up. And after doing that, in order to scale the 0 to 255 values into a values between 0 to 1, we can just simple divide the array itself by 255. And with NumPy, the simple division is applied element-wise, meaning that every element in the array will be divided by 255. In order for us to be able to do this, but however, first we need to make sure that all the numbers are in the correct format, and the format is float 32. So for doing that, we're going to actually just click into that, and the first thing that we do in this block is just to ensure that the training data or the data that we're using uh, is using the as type build method from NumPy for ensuring that all the data or all the elements that we have into our array are of type float 32. And after we ensure that that is cool, we can now divide our whole array by 255, so we can check out which ones are black, which ones are white, or which ones are zero, and which ones are closer to 255, right? So we do that, and if we print our matrix shape of our data, now we're going to see that uh, now we're going to see that our shape has changed into a 700 by 84 matrix. All right. So notice how the training shape went from 60,000 28 to 60,784. 784. So now our X data or our input data is ready to be used. Now let's just modify the Y data as well, right? So for doing that, we need to actually try to check up the amount of classes that we need, right? So right now, as we saw earlier, the output that we is just a simple number image. So while this is easy for us to understand, in order for a machine learning model to understand all these categories, the output needs to be an array in an array format. So for these, we can use something that we call one-hot encoding. Essentially, each unique value, like 1, 2, 3, is going to have a slot into an array that is going to have this total number of unique values. This is a really common technique that we use into another field of machine learning called natural language processing. One-hot encoding is one of the most common techniques that we can use for just doing that. And let me show you how one-hot encoding actually looks. Why only 250? Yeah, it's because of the color code. It is because we were checking up that before. So it is because, as you can see here, and let me just open this image in a new tab and zoom it a little bit more. Um, Usually, what computers do is use RGB, which is this color code that we use for each one of these colors. Um, but originally, computers didn't have like any colors, right? Like light goes just from black to white, right? Like this. Oh, there you go. Like we have the RGB space, and also we have the black from to white space, right? So we can see if something is darker or something is lighter, right? So usually we denote that by something called 0 to 255 grayscale. And this grayscale helps us to understand which pixels are actually black and which pixels are white, and which ones are grayer than others, which one are brighter than others, which one are darker than others, and so on, so on, so on. So we apply this for different colors, and also we apply this for brightness and darkness, right? So what are we going to do is we're actually going to do the same thing for numbers. You see, we are using 28 by 28 image, and in this image we're actually seeing that the white colors are represented as zeros, whether the 255 colors are represented as black. That this is actually in reverse. Oh no, yeah, this is normal. No, yeah, it is in reverse, right? Oh well, some grayscales use zero as dark, and some grayscales use zero as white. So I don't know what that happened, but it's the same principle. We're using the white colors as zero, and we're using the 255 colors as black, as fully black. But you see, there are some pixels that are not actually black or white, are like gray, like totally gray. So this is why we use this grayscale from 0 to 255, so we can check up like which parts or which pixels do have like um, gray colors, which one have dark colors, which one has bright colors, so on, so on, so on. So our model can use something called feature extraction, and feature extraction is just checking up like in images how similar those certain sections or yeah some sections of the matrix that we're using are similar to other matrices that we're going to be training our data with. So yep, let's just continue with this. So okay, yeah. So yeah, but before doing that, we were talking about one-hot encoding, right? And I was going to show you how one-hot encoding looks. There you go. You should be seeing it now, I think, and there should be enough. Some let me know if you can see it correctly. Okay, cool. So yeah, this is the thing that we are going to be using actually, right? So we have one hot encoding. Oh well, I didn't like this example at all. Yeah, this one looks better. No, Ugh, freak. Okay. Give me 1 second. Yeah, this should work. Okay, yeah, and I think you should be seeing it correctly like this. Why does it look so bad? What? Okay, this one is the correct one. Yeah, there you go. Let's go. Okay, yeah. So we have this example, right? We have an array of colors, which they are green, red, and blue. We have three different class of colors. We have the three different colors. As you can see here, we are going to denote just the colors that we have activated for. Actually, this example is weird. Oh my god, it's so hard to find just a good example of what a hot encoding. Oh yeah, there you go. This one is a classic one. Okay, yeah. And yeah, the third one is like the end. Yeah, so we have three different colors, color red, blue, and green. Each one of these colors is in an array of colors with an ID. And what we do in one hot encoding is that actually, as you can see here, the only three classes that we have is red, blue, and green. So what are we going to do is to create a new array that is of the size of the amount of classes, and we're just going to activate the column that represent the class that I'm seeing. So for example, in the first element that we have in the left matrix, the first one represents the color red. So how do we represent the color red on 100 coding? So you can see that we have the color red column, the color blue column, and the color green column. The only column that is activated is the one that we're watching, right? Which is the color red column. So the other ones are deactivated. And what I mean with activation and deactivation is just we are saying that one thing is activated as it's marked by 1, and the other ones are marked as 0. So yeah, we're going to do the same thing for each one of the other colors. So color blue is going to be activated on the middle, color green is going to be activated on the right, and when we see color blue again is going to be activated in the middle, and so on, so on, so on. So we're going to do that for the same numbers that we have. So as you can see here, we have just numbers from 0 to 9, right? So we have how much? 1, 2, 3, 4, 5. We have 10 classes. So what are we going to do is it's going to initialize a new variable called number of classes, which is 10, and we're going to do one hot encoding, or we're going to categorize each one of the classes that we actually have inside of our data set. So essentially, each unique value, like 1, 2, 3, is going to have a slot in an array that is the size of the total numbers of unique values, like the example that we watched with the colors, right? So we're going to have an array of 10 elements, and we're going to represent each element by an array that is on, and other ones are going to be off. And this should be looking something like it should look something like this. Oh shoot. Yeah, you're going to see that, for example, number 0 is going to be represented by just the first element. Number 1 is the second one. Number 2 is the third one, and so on, so on, so on, until we reach the number 9, which is going to be represented by an array of all the activated values. Just the last value is the one which is going to be activated, right? So yeah, we're going to do that. So yeah, after doing that, we're just going to categorize each one of those ones by using to categorical function. And as you can see here, is not so hard to implement from scratch. We can just loop through all the data and append any unique element to a unique element array, right? But it is so easy because it sounds confusing, but we don't need to worry about anything because Keras has already a function to it, so we can use it. That is called use to categorical. So yeah, we are going to do that. So after doing all this stuff, we are going to see that we have an array of already hot encoded values, right? So for example, we see that we have C a 0 right here, and also we have C an 8 right here, and probably the other ones have like 1s, 2, or 3s, or things like that. So you don't need to worry anything particular. So now we need to build our neural network, right? So we're going to add dense layers and activation layers. Also, what happened in LP is terrible. Okay. Mm-hmm. Poof. Okay, give me just 1 second till I see what is going on right now. Okay, so maybe I didn't do it correctly. Oh, there you go. Let me pass you this through the chat. It's because I think I was using layers activation relu TF Keras layers in what it was. TF Keras sequential, TF Keras layers dense activation relu. What happened there? Dense blah, 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 blah. Let me see what did I did incorrectly. Yep, I open an array and get layers dense input shape. Activation relu. Was it the comma? Yep, it was a comma. Sorry. Yeah, just don't worry about it. I just add the new comma and you should be ready to go. Yeah, I forget to add this, or maybe I erased it on the last workshop. But yeah, just add the new comma to the second argument, like right here, and you should be ready to go. Basically, we are just building the new neural network so we can have a three fully connected network of our neural networks. So, yep, there should be all. So now we need to load our data, right? So now we're going to use the image data as a directory that we're going to use, and we're going to categorize each one of the images that we're going to have. And now we have another problem. Can we find directory data? Well, what happened here? Model fit. Blah, blah, blah. Okay, give me just 1 second. I think I'm having some problems. Model dot summary. Let's see what we're looking to. It is sequential. Okay, yeah. Then okay, okay, cool, cool. Okay, nice. So, oh yeah, we have not even like compiled our model. Oh, okay. So let me see if we are able to compile like this. It is compiling. So, oh, we yeah. So, so sorry for that. I think I used the wrong classifier collab. Yeah, I think there's a problem. I have a copy of the collab right here that I was using for just following it up like with comments and all that. Okay, so let's explain what are we doing right here. So the first thing that we are doing is just building our model, like saying, "Hey, I want to build a model like this one, which is going to be this dense. Is going to have four. It's going to have like this amount of layers. Is going to have this shape, and it's going to have all these parameters for all the stuff that I'm going to be doing, right? And after that, we're just going to call it model summary, so we can summary like all the characteristics of my model, and I can just check out my characteristics, and I can make sure that what I'm doing is correctly. And after doing that, we need to compile a model. So when compiling a model, Keras is going to ask you to specify a loss function and your optimizer. So the loss function we use here is called categorical cosentropy. And it is a loss function well suited to comparing two probability distributions. I know there's a lot of math, but don't worry. Here predictions are probability distribution across 10 different digits. Example, we are at 80% confident that this image is a 3 and 10% sure that it is an 8 and 5% that is a 2 and etc etc. And the target is a probability distribution with 100% for the correct category and 0 for everything else, right? So the cross entropy is a measure of how different your predicted distribution is from the target distribution. If you are interested in more stuff, let me show you a Wikipedia link that you can watch, and let me share with you in the chat so you can check out more of this. Oh, yeah, you can do it on Jupyter Notebook, so you can use it. And if you want to, yeah, totally, you can just do it on your Visual Studio Code or whatever you want. And you can use Jupyter Notebook so you can run it locally. Basically, Colab are Jupyter Notebooks on the cloud. So, yeah. Yeah, if you want to see more about cross entropy, just take a look into this. And yeah, let's just continue with this. So yeah, the optimizer helps determine how quickly the model is going to be learning and how resistant it's going to be to get a stock or to buy one. So there's a lot of details between these, so don't worry about it. It's just we don't need to go that deep into this. So yeah, now the thing that we're going to do is to train our model. So for training our model, we're going to oh no, not this one. We're going to fit our model like this. Let me show you and let me share with you this blog right here on the chat so you can use it. And don't worry about it. Like if you cannot follow up like all the stuff, I'm going to share a new notebook after the stream. So after doing this, what is going on? What is going on here? Nonsense. Wait. I think I'm tripping. Maybe it's the I really needed to add this. Case summary. Yeah, there you go. Yeah, I think I forget to add the auto shape that I wanted. Huh. Interesting. Yeah, sorry for that. Sorry for the confusion. So yeah, now we have already trained our model. As you can see here, we're just running each epoch. That is just a training batch that we are doing for a model. And after doing all the stuff, we have trained our model. So now what we need to do is to evaluate our model. So let me just remove all this stuff from here. And how can I? Yeah, just eliminate. And yeah, it was super different. Let me just eliminate the cells and split data, eliminate cell, and eliminate cell. There you go. All right, so yeah, we have just trained our model. So now the question is, how can I use my model? How can I check if everything is correct? So it is super easy. There is a really cool function that we can use that is called model that evaluate if we're going to use our test data and our white test data. So we're going to see the score between each one of them. And for those, that doesn't mean anything, but for the computer, it does. So now how we can actually check out like the predictions of the X test training model that, if you remember correctly, we divided our testing data into two parts. The first one was the training data. And we have also the testing data, right? So we check out like a prediction of each one of this. Each slot is each slot in the one hot encoding array represents a probability from 0 to 1 that a given image belongs to the slot class. As you can see, the predictions above the 7 element has the highest value, meaning that the image is mostly like it a 7, right? So if we want to check up like the whole images or like the whole representation of each one of the images that we have in our training dataset, we're going to see that if you use the argmax function of numpy, you're going to top or down the prediction that the model has done. So we can see that the first image is a 7, the second one is a 2, the third one is a 1, so on, so on, so on. And we can check up if this is correctly by plotting all the stuff right here. So let's see. Oh yeah, I forgot to add this up. Let's see if this is actually correct. Is it correct? Yep. So the prediction class said that we have a 7, we have a 2, we have a 1, right? So we have a 7, we have a 2, we have a 1. Also, we have a 4, 5, and 6. Do we have a 4, 5, and 6? No, we don't. As, what happened here? I found a super. Okay, let's see. Mm. Ooh. Looks like we have some problems right here. Oh yeah, no, no, don't worry. This is correct. This is correct, actually. No, yeah, this is correct. I'm so sorry. I was tripping myself. I forget that this is not the whole. It's just like for saying that the other elements and the final elements are 5, and 6, right? So yeah, we have a prediction of 0. The class is 0. We have a prediction of 4. The class is 4. Prediction of 1. The class is 1. The prediction of 4. The class is 4. So as you can see here, we have built our first correctly prediction model that it implies a lot of things that you still need to understand, like the whole process of the mathematics between it, like what are we doing? Because like for me, I don't understand them like either. Like if you don't, I don't too. But it's cool to show you like how you can build these awesome things, right? But behind all this stuff that we're seeing, like right here, like the plots, like the processing and all the stuff, there's a lot of mathematics going on. And I'm not the one who is who has the best capacities to understand and to show you how all the mathematics works. But it is cool. We have learned like super interesting stuff today, right? Like how we can build machine learning models, how we can use it on the web. We understood like the basic stuff of image processing, like the colors and the 0 to 255 grayscale, what is RGB, and how we can predict just processing, uh, the steps of building a machine learning processor, and all the stuff, right? Let me show you again the collapse so you can see the new version with all the stuff right here. And if you want to get more into here, into this, let me show you um, a really workshop that you can use. Uh, nope, nope, nope. Where is it? Yep, there you go. You have a really cool page that you can use that is called Kaggle. And there you go. On Kaggle, you have a section that is specified for computer vision. So if you want to learn more about convolutional classifiers, convolutional ReLU, maximum pooling, blah, 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 and you want to see more videos or workshops or things like that, you can begin this course with Kaggle, and Kaggle is also a really good resource so you can just learn more about machine learning, about data, about data engineering, computer vision, and more stuff. That, for example, if you like cricket, there is a lot of data sets for cricket. If you like more like soccer, like you have like soccer data sets that you can use for your own projects. So I encourage you to check out Kaggle. And let me show you, let me share with you the link of the computer vision course so you can check it up. And unfortunately, we have run out of time and we have not been, well, like we did a lot of things today, right? So I think we can call it a wrap. Um, if you have any questions, please let me know. If not, if you have some other questions that don't have anything to do with machine learning or computer vision, here's my LinkedIn. I'm going to share you with you right here. You can follow me on LinkedIn so you can we can just chat about anything that you want, like the MLH Fellowship, machine learning projects, how to apply to the MLH Fellowship, how to become a software engineer, something like that. And here's my GitHub if you want to check out like all the projects that we're doing on this and the previous Global Hack Weeks. If you want to follow me on GitHub or something like that, if you want to connect, you can just follow me and we can just chat. For my part, that was all. Thank you so much, hackers, for being right here. It was so good seeing you. It was so good building this awesome image classificator with you and seeing all the stuff that you are capable of. So thank you so much for being here. And I'll see you on. Let me see. I'll see you tomorrow. So you can check out how we can use AI with Streamlit, which is a really cool tool for building web pages with Python, and how we can implement AI stuff with Streamlit, right? So right now, the next hour, Binayak is going to stream a hacker hangout. So if you want to hang out with hackers, just be here in 1 hour. Is going to start the Binayak stream. So yep, I'll see you tomorrow. And it was so nice to hanging with you. See ya. Bye.